Okay, so I think we're live. Hey there, everybody. Welcome to another live talk for the. Oh, sorry, I can hear the background. Okay, so I think I have a live stream in the background. Uh, yeah, okay. Sorry about that. I could hear myself. There was a bit of a loop. Sorry, I can still hear myself. I wonder why. Sorry. Um, so if someone there in the chat could tell me here on Slack if there's an loop. Oh, here we go. Sorry, I had the video open on another tab, but it's all working now. Thanks a million for your patience. So perfect. So let's get things rolling. So just to give a little bit of a roundup of what's going to go on in this event, we're going to start off with a few establishing questions to get to know a little bit about the problem area, to get to know Marcia a little bit better. After that, we're going to move on to Marcia's presentation, which will probably take around 30, 35 minutes, more or less. We're going to have some time for questions at the end after the presentation. So feel free during the talk to add your questions to the chat, which we'll be able to see here. And after that, we will cut it off at around an hour. Marcia has been really generous to give us an hour of her time, but we do have that cut off. So thanks a million for that. And before that, we're just going to start off with a tiny bit of housekeeping, just two things to keep in mind. The first thing for the community members who are going to be joining the Commissar Weekly meeting, that's going to take place directly after the live talk that we're having here. So it's just pushing the talk 15 minutes a little bit further than what it usually is. So see you all there for the Commissar Weekly. And the second thing, just a quick reminder that the Hacktoberfest is past the midway point. We still have 10 days left in Hacktoberfest. If you're new to Hacktoberfest, feel free to check out the webinar that Kunal and myself put up on the Tailwarden YouTube channel. You can get started there. But if you already know your way around Hacktoberfest, feel free to head over to the Commissar repository. You'll be able to find all the Hacktoberfest labeled issues there that you can pick up and get working. Also, we're really happy to share that we've shipped the Commissar badges for Hacktoberfest, so which are pretty cool. So if you do get those 4 Hacktoberfest related issues shipped, you're going to get that cool badge. So big shout out to the design team for shipping that. So that's it for the housekeeping items. Now I'm very, very excited to introduce the speaker because I must admit, as a DevRel professional and also as a Spanish speaker, Marcia's work is work that I've been following for a long time. She, as you'll probably see in the presentation, she has a real gift for breaking down complex topics into really kind of like digestible and understandable chunks. You might know her from her YouTube channels, Fubar, and also, if you're a Spanish speaker, Marcia Villalba, where she shares her expertise and general knowledge around cloud topics, serverless architectures, and much more. At the moment, Marcia is a principal developer advocate at AWS, and you can also catch her podcast, which is on technical AWS topics, also in Spanish. But she's also a regular contributor to the AWS news blog and helping us all keep up to date with any AWS launches and AWS topics. So please give a warm welcome. Thanks a million for joining us, Marcia. If I got anything wrong, please let me know. But in your own words, could you tell us a little bit about your background?
Well, I don't think there is much to add. You gave a quite good intro. But yeah, I've been doing this for many years. First as part of the community, then I joined AWS. And I've been working with serverless since 2006 when there was nothing online. So that's kind of my inspiration to help everybody to come to serverless and to play around with these technologies. Because when you start in a tech and there is nothing that you can Google, it's quite painful. So yeah, that's me. Yeah. I'm looking at weird angles because I have my camera here and the screen where I'm looking at Shake here. So sorry for that, but then when I'm presenting, I will be looking here. So yeah.
Perfect. Yeah, no worries about that at all. But yeah, so whoa, 2006. And how did your like serverless interest get started? Because I'm get like AWS Lambda was not a thing in
No,
2006,
well,
right?
it was already a thing. It was launched
Oh,
2016, sorry, 2006 when I started with the cloud, but yeah, 2016 when I started with serverless.
okay.
Yeah, yeah, because Lambda was launched in November of 2014. Sorry for that. And then the first times with Lambda, there was no integration with API Gateway. I'm a developer, so it was like, I don't care about this thing. This is an ops thing. And then they add the integration to API Gateway, and then it's like, so yeah, it was a revelation how many things you can build with that. But still, in 2016 there was nothing to Google around, so the story still is true. In 2006, when I started with the cloud, there was very little you can Google as well, because everything was
Yeah,
starting up. Like the first services were basically starting, and it was hard. AWS had
I,
quite little tooling, and yeah, it was
I
a
can
pain
I
as
can
well.
imagine.
So I like to
Um,
start from early beginnings.
yeah, and since you're probably the person to the perfect person to ask this because since say for example, yeah, AWS Lambda has been around since 2014, but serverless technologies have been around for a lot longer.
Well,
But
the
go ahead.
cloud is serverless, as I always say. The first service AWS launches was SQS, and then S3, and and EC2. So those are like the first three services that we got more or less around the same time. And SQS and S3 are serverless services. They are the ear to what we call serverless. It's like no managed infrastructure, pay for how much you use, like high availability, no need to worry about the availability zones. It's just a regional service, and very little infra to manage. So everything is the same principles that we use to mention something is serverless. So yeah, we started with that. And then I think because the way to do compute by then was with virtual machines, started with EC2, but as we move forward, we can see more and more serverless options for compute, and I will be talking about some of them today, not only Lambda.
Amazing. But I'm just wondering if we look at other versions of compute and especially like, do you think the kind of the growth of, for example, Kubernetes kind of put the kind of broad adoption of serverless kind of or made it less attractive over the last few years? Because I think serverless now is much more kind of like widely spoken about and widely implemented, but it wasn't always like that, right?
Well, I think to start from the beginning, serverless is a marketing word. Before that word was invented, it came more or less around the same time with Lambda. Nobody was talking about serverless. They were just using the serverless, the managed services, without really thinking what they were. And now it's more adopted because people are more aware that those services are serverless, and AWS is branding their product with, oh, this is serverless, this is serverless. So you start seeing more adoption of that. But the idea of managed services is something that has been as old as the cloud.
For sure, for sure. And I think yeah, they definitely for relatively newcomers onto the scene like myself, the kind of like wider just kind of awareness of serverless comes from people like yourself who do a lot of work covering serverless and creating serverless content. And I was just wondering if I look at your YouTube channels and the content that you put out, is there any particular AWS managed service that you enjoy covering the most or like playing around with the most? Because if I look at like the latest stuff that you put out, of course you cover Lambda and a good deal. Kinesis Streams is also
The thing is
a
that
widely.
to build an application using managed services, you need to have multiple different services. So for me, these services are like Lego blocks. With one Lego block, you cannot build anything. So you need many of them. And sometimes you need the same many times. So you might need many Lambda functions. Sometimes you might need different shapes. So you might need a Kinesis here, a Lambda here. You might need a Dynamo table. And with all these different building blocks, you will build your application. So if I say, oh, I love Lambda, yes, I do love Lambda, but with Lambda alone, you cannot solve your problem. You need different integrations, you need different services to help you to move, like to get those requests if you're working with HTTP, or to capture the events, or to process the data like coming in your data stream pipeline. Lambda is very powerful as a compute, but it needs other things to solve the problem. So it's hard to say I can only keep this one to solve all my problems. No. And that's one of the biggest challenges when customers are facing serverless development for the first time, because they realize that in order to get started, they need to learn 4 or 5 services. The thing is, I teach in university the course of serverless in a couple of universities. And I always tell them the same, that the starting curve is quite fast because these services are quite simple. So yes, you might need to know many services, but it's just basically how to do hello world in many services, and you can get started building quite cool applications. Sure, to get to a production super performant amazing app, you will need to deep dive, but that happens with everything in life. But if you want to build your simplest Kubernetes application, that's another challenge, and it's even harder. So yes, it's more services, but AWS or the cloud itself will take the heavy lifting for you. So it's just basically, oh, well, I need to know that I need event bridge if I want to do events, and just create a rule. So it's a small concepts, little things here and there, and then you can get started.
Yeah, I kind of realized when I asked that question that it's kind of like asking like an Italian chef, hey, what's your favorite ingredient to cook with? Like they're never going to say, oh my God, like pasta. Like I would just serve people pasta and I'm happy with that. No, like a plate and a recipe, you need a bunch of different ingredients for it to be worth your while.
Not many, but some important ones.
Some important ones, exactly. Well put. I'm just wondering, just for the people who are like interested in going a little bit deeper, and also we have a few people here in our community who are also content creators and like writing blogs and writing technical content. Could you tell us a little bit about the AWS community builder kind of tracks, and especially like the hero tracks that come afterwards? How do they kind of like relate to like developer relation roles, if they do at all, or what does a content creator need to do to apply for those, for example?
Well, the only one that you can apply, well, besides the career at AWS, that's a shop, so you can always apply. But
Sure.
in the community programs, we have the community builders, as you said, and then we have the AWS heroes. So the heroes you cannot apply. So that's something that AWS will need to find you and will do an internal review process. And if that's approved by multiple parties, then you will be considered a hero. But the community builder is a program that is amazing for content creators. You just we have 4 times a year an open application where you can go and apply for it. And basically you need to show that you are creating content related to AWS, either blogs, Instagram, YouTube, TikTok, whatever. It doesn't matter. It can be open source. It can be you teach at a university and you have 1 million people that are like watching those courses. But you need to prove that you are doing content around it. And then that gets reviewed, and every quarter we approve a lot of people. And well, there's different tracks, as you say. It can be serverless, it can be DevOps, it can be databases, it can be, there is multiple tracks, and you need to choose which one you are interested in. And yeah, so stay tuned. Usually DevRel, that is the team, the marketing team for developer advocacy in AWS, will be sharing these dates when this is open, so as many people as possible can enroll. And you get a lot of perks. You get discounts in some of our major events like reInvent that is coming up. You get credits to play with AWS, so it's basically free unless you do like production workloads, but it's quite a lot of money. You get a lot of swags, you get access to the product teams and some things that are not even released. So we ask you feedback. We want to help you as much as possible. We give you internal talks and things that are not available to the broader public. So it's quite a nice program.
Perfect. Thanks a million for that. So moving on to the talk and to the context around the talk that you're going to give us. If I'm not mistaken, I've heard you speaking before that when it comes to implementing serverless, rarely we're talking about companies starting like an application from scratch, like a greenfield application, and most times there's some sort of migration involved. Is that why this particular talk that you're going to give is so relevant in your opinion?
Well, migration is something that we cannot avoid. Sure, as engineers, we would love to start greenfield always, but that's not the case. So sometimes we are on premise, or we are just a developer building something in our home and hosting it in our, I don't know, under our table, and then we want to take it to the cloud, or we want to sell that product somehow, or we want to scale it. And there is so many reasons why developers will start with a web app, because it's a natural thing. It's what you will find the most of YouTube demos on how to build your web application are on building it either on premise or on computer under your desk. So then how you put this in the cloud in a way that it can be production ready, and it doesn't cost you much, because that's something, at least when I was thinking about this talk early on, is there is a lot of workloads that people don't want to pay like a fee for having it running. Maybe it's just they are playing with this, or they are just launching a product and they don't know if this will be like something that will go big, or is something that they are starting and they are developing, and they just don't want to pay for a big fixed amount. So serverless is kind of a tempting situation, that you can have a web app doing all this kind of interesting compute, but in a way, when you're not using it and you don't have any traffic, it costs you zero. And it's like, oh, how you can do that, and how I can still get the benefit of having this web application that I can locally test, that I can run it in my own computer. Is that something that is even possible without really refactoring my whole application to be like 1,000 Lambda functions? So the origins of the talk is somewhere there, because that's something I hear a lot from customers when I go around and chat with people, like, what is your biggest challenge to start with serverless? It's just, I know just how to do web apps. and you still
Yeah,
can
it's
do
kind
it
of like,
yourself.
I know it exists, but
Yeah,
can I
exactly.
really do it?
Yeah. But again, this talk will guide you through a lot of services. So that's part of the serverless way. Everything is a different service. But after you learn more or less what the services are, they're pretty straightforward to get started.
Perfect. So yeah, so speaking of the talk, can't wait to jump in. So if it works for you, we can get things going.
Good. So I already give the intro here. So I want to start this talk with a little story from my own experience. So this talk came from speaking with customers, and it also relates to my first encounter with serverless. Because I didn't know how to do migrations. This was 2016, as I said, and we have to migrate this application I have been working now for a couple of years. It was traditional microservice applications hosted in little containers in the cloud, and we didn't know how to do that. So instead of just doing small strangler pattern, refactor little by little things. We just stop everything for 9 months. We rewrite the whole thing. And then 9 months later, we opened that to our existing customers. We did the transfer of the domains, and flood of customers came in, and we cry a lot. So it was very, very painful. So I think sometimes this idea of let's refactor everything, we know that it's not the right strategy. We know the strangler pattern is the right strategy, migrate little by little. But then if you're not in the same ecosystem or in the same in the cloud even, it's very hard to do the strangler pattern. So the idea of lifting and shifting without touching your application as much as possible, have traffic coming in already, and try that serverless approach and getting in the cloud as fast as possible. And then little by little start peeling those pieces and migrating your application to obtain the 100% benefits of serverless that, well, with lift and shift, you will not get it, but you will get a lot of the benefits. So that's kind of the way we are going. So we are focusing on the lift and shift. And because I want to show you how to migrate a full application, we are going into the different bits that a normal web application has: a database, a backend, a front end, a part that has authentication and authorization, and a little bit of storage. So we are going to check how all these different bits and pieces can be migrated to the cloud. For this demo, I already presented myself, so I will skip this one. For this demo, I'm doing the typical MERN application: Mongo, Express, Node, and React. So the application looks like this. It's a very simple e-commerce. And you can see it's on-prem in my local host. And most of the operations that you see in here are happening in the backend. So all the filtering and things like that are done in the backend. I can buy some products. There is remove them from the cart. All the typical things that you can do in an e-commerce. There is a user that is logged in. So basically, when they purchase some products, there is no Stripe or anything configured. It's just test. The user can see the history of the orders that they have done. They can log in, log out, and they can upload their own products if they want to. So as I said, this is the typical application. And a lot of the things I'm going to show you here are 100% only for this architecture. It can apply to other architectures because most of the services are quite agnostic of the frameworks that you're putting on top. So for the database Mongo, I have it in my machine, in this case, running on a container. Then the server is Express and Node.js. Again, a little instance running on my machine. And the web front is a React.js pointing to the server to do some API calls. And in my case, when I started playing with this, everything was localhost, but it could be exactly the same if you have it on premise. So as any migration, there is requirements. So it's important for a demo migration that I also put some requirements, because if we don't have requirements, then we can do whatever we want. And that's not the challenging part. So I'm a serverless expert, so I wanted to have an environment that scales to zero, because that's what customers were telling me, that they want to scale to zero as much as possible. They don't want to pay for idle. They don't want to, that's something that it was a big no. And they want to scale up automatically. And that should be pretty straightforward. They want it with no operations, that it just happens. If they put this website or e-commerce and they put some product on Instagram and that product becomes viral, they want that the product is able to scale up without them worrying too much. Configure as little infrastructure as possible. The audience for this migration is developers. Developers are not interested in hard, complicated networking in the cloud, setting complicated instances in the cloud, worrying too much about how the whole infrastructure in the cloud is. We want to make that as small as possible. Then we don't want to worry about the availability of the application, meaning that we don't want to think about how many replicas of our application we need to have, in which availability zones. We just want to put it in the cloud, and the cloud will take care of making sure that our application is available all the time. And then again, this is a lift and shift, so we want to make as few changes to the code as possible. So let's start with the database, and the database is a little bit cheating in the sense because I'm using Mongo. I have it Mongo in my in a container in my computer, and if we go through the serverless alternative of Mongo, it's Mongo Atlas. So this is extremely simple migration. You just create an Atlas cluster. You can get one for free with a small connections and size, but that's for testing purposes and for small production workloads work quite nice. And basically, you just create the cluster, you get the data from your local database, and then you put it in Mongo Atlas, and then you're ready to rock. This takes 5 seconds. So the database is done, and don't forget to change the URL in your backend application. Now let's go to the juicy part. This is the part that there is kind of a lot of questions, how you can make a serverless backend. So we have many options. We have Fargate, that is our serverless containers, AppRunner, that is even more serverless container application. I will explain that in a second. And then the famous Lambda, that is functions as service, totally serverless. So let's look at our migration requirements and see how these align. So first, let's start thinking about a typical web application. So if we would like to put this in a virtual machine somewhere, we will need to have this virtual machine with operating system, the runtime, the application on top. We'll need to worry about the availability. So we might need to have multiple copies for redundancy and scale. And then we need to have a load balancer so it knows where to send the request. And then if we want to do this automagic, we will need to have some auto scaling configured. And we need to have a pipeline for CI and CD. And then you can start seeing how this becomes very complex to run on scale on premise. So then in 2006, when I started with the cloud, we released EC2. That was something quite revolutionary because the idea is not to have any physical servers. And basically, you can throw your application into a virtual instance. But again, you have to worry about the operating system, the runtime, the application, the load balancer, the auto scaling, the CI/CD. It was a lot of work for a developer. I'm a developer. I didn't care about all these things. I will expect that ops will do it for me. Luckily, in 2017, we launched Fargate, and Fargate took everything one level up. More responsibility for AWS, less responsibility for the customer. So now the customer only have to care about their container image with the runtime and the application, how to auto-scale those containers, a little bit load balancing in the front, and then the CI/CD pipeline. This looks better, but still, in my opinion, as a developer, this is quite a lot of work. And then in 2021, we launched AppRunner. And AppRunner take everything one notch up. More responsibility for AWS, less responsibility for the customer. And I'm all for that. In here, you just create an application. I'm a developer, creating an application is good. And then you put it in GitHub, for example. And then AppRunner will make sure that it's containerized and it's deployed in the cloud. It has multiple replications, it's auto scale. It has a pipeline for deployments, and everything is handled by AppRunner. So this is my type of service as a developer and not as an operations. So if you didn't know, AppRunner is a very abstracted service that allows you to create web applications and API hosting in the cloud. So here, basically, you can put front ends, you can put backends, mobile backends, APIs. And if you are using one of our supported frameworks, that there is quite many, like Node.js in our case, then you just throw your application, not containerized, into GitHub, and then AppRunner will take care of everything. If you're using another framework that is not supported by AppRunner, then you will need to build a container image, but that's something quite simple. And AppRunner will do everything for you. So basically, as a developer team, you have two options. Put your code in GitHub with the supported runtimes, or then use the container image. And then you just create a connection from AppRunner to authorize the access to the code, and then create permissions if you're using the container image to access that image. And then App Runner will grab that content and build a whole service for you. It will create the machine, it will provision the machine, it will create health check configuration, auto scaling, deployment, and everything you need. And it will also add CI/CD to it. So whenever you push a new commit to GitHub or you push a new image to the repository, it will just redeploy everything. And then you get back just an endpoint that you can use in your clients. This service is not 100% serverless, so it doesn't scale to 0, but it scales quite nicely. To idle. So it's a service that I would recommend to many customers that don't want to go through the Lambda roadmap, and they still want to take advantage of this kind of almost serverless experience. And then we have Lambda, and Lambda is great, but we have heard many times that Lambda doesn't support web applications. And well, officially it doesn't, but we have built in AWS a tool that allows you to develop and put web apps on Lambda, and that's called the Lambda Web Adapter. So this is an extension that was built by internally by AWS, and you can start using it. The link is in the screen, and I will give you a link with a lot of links at the end of the presentation. And basically what it does, it grabs all the different requests, events coming through your Lambda function, like API gateway requests, load balancer requests, functions URL requests, and will grab those events and transform them into an HTTP event that your web application can understand. So basically, you just don't need to change your web app. You just throw it inside that Lambda function. And with that adapter, it can start working with any of the typical APIs services that AWS have. So as I said, this is an extension. It supports container images and SIM packages. So this means that you can work with any runtime that you want if you just put it in a container image, and you can use any programming language. So if you want to use PHP, for example, that is not a supported runtime in Lambda, you just pack it in a container and then you're good to go. And the cool thing is that you can do local testing and local development as you're used to do with your applications. And the only thing that is when you deploy to Lambda, and then the web adapter will take care of all those HTTP to event connections. So this is a fully serverless, and it adheres 100% to our requirements. So this is a great solution. Now, when we have a backend, we need to have an API. So if you are using Lambda, you need to think about load balancer, API gateway, or Lambda functions URLs. So all of these work with the Lambda web adapter, so you can pick any. And then if you're an App Runner, you already have a secure endpoint behind the load balancer. So basically, that's solved for you. But if we want to go through the API road, I just want to introduce you the functions URLs. I like them a lot because these are part of the Lambda service. They're kind of free in the sense that you don't need to pay extra for using them. And it creates an URL that you can invoke a Lambda form. So it comes with authentication, so you can put it behind a role, or it supports CORS, so we all love CORS. If you want that, it has some kind of metrics that you can understand how your application is performing and how your URL is performing. It's a very low feature solution, but for many customers, API Gateway has too many features and maybe it's a little bit costly. So Lambda functions URLs might solve that. And if you're working with functions URL, you have the similar solutions like the input payload, so you can pass something in your path. You can have different HTTP methods, or you can have query string parameters as you will have with any API. And the same with responses. And if your Lambda doesn't return a response, Lambda will infer it for you and just return it. So this is something that is very natural to work with. And the cool thing of Lambda functions URL is that it has the same limits as Lambda, 6 megabyte payloads, up to 1,000 transactions per second in a default account, and then you can increase that to tens of thousands, and then the 15-minute timeout. So for example, if you are building something that is returning a buffer and it has a streaming, for example, this is quite cool because you can do it for 15 minutes. If you're using API Gateway, it only has a 30-second timeout. So now we have migrated our backend. We can either do it with App Runner if we don't care the cost for being idle, or with the web adapter and the Lambda functions URL. And now it's time to start migrating our web app. And for that, we have a couple of options that are quite serverless. The first one is Amazon S3 and CloudFront, and the second one is Amplify. So Amplify is a little cheating here, because when you do hosting and you want to host your web application, it's using S3 and CloudFront in the background. So for this particular example, I will show you Amplify, because it not only hosts your application, but it also allows you to build it. So it has quite a lot of features to build front-end applications. It has a lot of libraries that help you to connect to your backends. It has tools to ship your applications. Basically, you can, as we are seeing, we are hosting it. We are going to use the CI/CD. It has a lot of, if you want to have multiple stages, it's pretty easy. You can connect it with your GitHub, and whenever there is a new commit, boom, it will appear and deploy your application. And then you can always extend it with AWS CDK. So the services I'm going to show you here, as I said, are the hosting, how to host your application. Basically, Amplify will host it using S3 and CloudFront in the back, but you don't need to know anything like that. And then the continuous deployment, that is a very important feature for any developer. Just push your code to GitHub, do a new commit, and that should get reflected in your in the cloud somewhere in your stage that you're working. So this is how Amplify looks, and this is how the CI/CD looks for example, for my main branch. You can see that there is 4 stages, and you can basically add test, you can add different configurations on the dependencies, and do all kind of interesting things in that application. And if you want to have multiple branches connected to different stages, you can do that easily. And also it allows you to have, for example, preview for pull request, and quite a lot of interesting things. And if you want to create an application with CDK, you can do it with infrastructure as code. It's very simple. Just configure the GitHub repo, then set up the environmental variables. So your front end is totally agnostic of your backend, and the way that you are kind of connecting these two is with environmental variables. And then choose the branch on the repo that you're going to be attaching to this stage, and boom, you're done. And then in your front end, the only change that you need to add is to create a file called Amplify YAML that will basically connect those environmental variables from Amplify to whatever is on your React application. And that's kind of the connection between the cloud infrastructure, that backend into your front end, and your front end can be totally agnostic of what is going on in the backend. And those environmental variables look something like this in Amplify. And the cool thing here, you can see in the side that it says branches. So if you have multiple branches, you can have different environmental variables for the different branches. So different server ID, for example. So now we have migrated the front end, and then we are done, or not. We are not. There is some issues. So this is how our application looks. You can see the URL. We are in Amplify. This is hosted using Lambda Web Adapter, Amplify, and the database is in Mongo. So I will log in with a user that I migrated. It should be working. And let's see what happens. I'm not logged in. What happened? Does somebody knows? Well, it's a quite simple case, this one, if you understand how Lambda works. Lambda is a stateless service, meaning that for every call, it will start a new environment. So when we do the login, because we have not changed the code, our application was saving the session in the server memory. And because when we want to get the products or get the menu that it should be displaying now you're logged in, it will execute a new Lambda function that doesn't have that session in the memory. So our functions are stateless. They don't share this session. They don't share this memory at all. So we need to change that, and we need to solve that problem. So there is many ways to solve that problem. One way is to create your own authentication microservice that will host that session and will do that outside of your service. Another one is to use like a ready solution, like putting a little memory database in front of your Lambda function and storing all your sessions there. And then you can use some managed authentication service that will help you out. The problem with the first two is that they don't adhere to our migration requirements, and they make it a little bit hard because we will need to worry about the availability. This ready-like solution is not serverless, and if you create your own microservice, I don't know what you're going to do, but maybe you need to worry about the availability. Well, there's a lot of changes in the code that you will need to put. You will need to configure a lot of infrastructure for these both solutions. And in some cases, the solution that you come up and the Redis-like solution might not scale to zero. So if we go through the managed authentication service, the kind of alert there that we have is that we will need to do changes in the code, but then the rest will adhere to our migration requirements. And the changes to the code are my favorite type of changes. There are those changes that we are removing business logic, and then we are relying on someone else to handle that. So for example, we are going to remove the whole login, logout, create new users, manage password, and all that from our backend. And we are going instead to call the managed authentication service. This managed authentication service can be anything. There is many online, and I will be using Cognito, that is the AWS one, that comes extremely well integrated into all the services I'm going to show you, and it allows you to create users, to log in, to log out, register, to manage password, and then to give permissions to the different AWS services. So basically, Cognito has two big features, what we call the user pools, that's the directory, and how to manage those users. So it will allow you to create and handle those users. What happens when the user forgets the password? What happens when you want to validate that user with an email or with a phone? Or what happens when they want one-time passwords? Or what happens when you want access tokens or things like that? That's all handled with the user pools. And then the identity pools are very interesting, and that's very unique from an AWS service or for a managed authentication service that allows you to get temporary credentials to AWS. And you might be wondering, Marcia, why I want to give my users temporary credentials to AWS? Well, if they need to use any service in AWS, they need to have permissions. So for example, if they need to upload an image to S3, for example, to create a new product, as we have in our example, they will need to have credentials to access and to put images in S3. So you don't want to make your S3 bucket open. You just want to give permissions to those logged users to be able to put images in S3. So we need to change this in the backend in order to remove that extra logic that we have now. And then in our frontend, that instead of calling our backend, for example, for login or for logout or for creating a new user, it calls Cognito. So here is, for example, an example of how our frontend will look. So now we will be using the Amplify library that will do the authentication. And this is using Cognito. Basically, you just auth.signin, and then you pass the username and the password, and it will go to Cognito. It will check that this exists, and it will just say, hey, here is the user is successful, and we're good. So now we are ready or not. Let's upload a new product and see what happens. So let's upload a new product, and my image is not uploading. What is going on? Well, this is another perk of Lambda. So when we had our original application, our images were stored inside our backend in a folder called uploads. That's quite a normal way of doing this type of applications. If they're small, it's maybe not the optimal, but it happens quite often. Then we grab our backend code, we throw it into our Lambda function without changing it. So now our uploads are inside of our Lambda function. That's why we can see all the images like perfectly, because they are there, they are being loaded. The thing is that when we upload a new file, we cannot change our Lambda functions. Lambdas, after they are deployed, they cannot be changed without being redeployed. And we don't want to redeploy our backend every time there is a new image uploaded. And then also there is a limit of storage in the Lambda functions. We can go up to 10 gigabytes, but that's a lot of images. So for this, we have a couple of solutions. We can put an elastic file system, and then we don't change much of the code. Or then we can go through the Amazon S3 CloudFront solution. The file system is quite simple to use in the sense of the code, but then we will need to do some availability management. And then we need to configure infrastructure, because that's not pretty simple to use in the infrastructure part. But then if we go through the Amazon S3 and CloudFront, the infrastructure is very minimal, but we will need to do some changes in the code that instead of using a file system, as we are using originally to have this upload folder, we are going to use the storage services like S3. So here we are planning to store our images in S3 and then use CloudFront, that is the distribution network, to make sure that these images get fastest to the customer. So CloudFront is a distribution network, content delivery network that has over 300 locations all around the world. And it works very simple. For example, imagine you have a customer in Australia, but your application is deployed in Ireland. If the customer comes from the first time to your application, or a customer in Australia comes for the first time to your application, they will have to fetch that image from Ireland. And that will take a while, because it doesn't matter how much performant everything is, there is still the latency of being in the other side of the world. But what CloudFront does, it will store a copy of that image, for example, in their local endpoint in Australia. So whenever that user comes again, or another user in a similar location, then they will have that image ready for picking up in Australia. So this will be super fast. And we want to have fast responses, because first it's cheaper, and then it also makes our customers happy. So then we need to modify a little bit our front end in order to use this CloudFront S3 solution. Basically, when an image is uploaded, put it in S3. And then when an image is displayed, we want to show it from our CloudFront distribution. So here we are uploading an image. So you can see that we are using again the Amplify library that will connect to S3 to put this image in a particular file in a particular bucket that we configure. And then we can create a new, in React is called like a new object that we are going to use whenever we want to show an image. Instead of showing HTML image, I will be using a CloudFront image that will grab that image information and show it from the build, from the distribution. So in this case, I just, every time I have an image, it's just using this component, and I don't need to think much, and it's quite simple to use. And all the images in my application I'm being distributed from CloudFront. So they're very fast. They're cheaper for me to maintain, because the connections from CloudFront are way cheaper than to connect to S3. And it's a very experience for everybody. So this is the solution now that is being deployed into the cloud. You can see that we are using Amplify. This is the site. Everything is quite snappy. This is real time, so you can see how it works, except the typing that I'm just picking everything up here. I'm registering a user. Everything else is on real time. So I'm creating a new user. I'm confirming this user with a verification code. This is all handled by Cognito. And now I can log in, and you will see now that the login is successful. You can see that the menu changed, and I can upload images and do everything that I'm expected to do in this application. So it's pretty nice, and it just works quite fast. So if I want, I can sort, and all those sorting is happening in the backend against the database in this case. So we can just add to cart. We can purchase the item. And then we can see that the item has been purchased. If we check the history, it should be also appearing that there. So it just looks as we want. So a couple of things I always get when working with serverless is that it's not performant, that it's slow, that it sucks. It's great for develop, like from the cost perspective, but it's very bad. I will tell you, no, I did some performance analysis here from the front end. For that, I use a page called Page Speed Insights that return how the application performs. And then from the backend, I ran quite a lot of load tests using artillery to understand the performance of my backend. And also, an important thing when we're working with serverless is understanding the scaling and the bottlenecks. That's something it's always good to understand when you're working with so many different services. So this is the page speed insight. So I'm running this against that Amplify. Don't check the mobile because it's not optimized for that. But for the desktop, that is what I optimize for. The performance is very, very good. And the backend checks, I have them in a YouTube video. You can check them there. I will give you the link at the end. But I run a lot of load tests that look like this, that are against the API directly. So this is not testing the front end, this is testing the back end. And then I can make sure that everything works pretty well. So more or less, we have achieved all our migration requirements. If we are working with the Lambda solution, our environment will scale to 0 and scale up automatically. It will scale up to what you have tested in your load test. There is some limitations. Mongo, the free tier, has some limitations with the connections, and you might find some challenges with that. So it's good to do some load testing. If you don't want to use Mongo and you want to use some AWS service, that's something I will show you in the videos I will share with you, that how you can migrate out. Then if we configure quite little infrastructure, it seems like there is a lot of services, but really it's just saying use this service with this thing, use this service with the thing. There is not much networking. There's nothing networking. There is no instance. There is no real bits of infrastructure that we have configured here. We don't have to worry about the availability. Everything is handled by the cloud, and the code has suffered quite little changes, and the changes that it has suffered is mostly removing code and pointing it to some other service that will handle that. So what's next? Now you can do the strangler pattern, refactor the product API, for example, and see how you can make it better. Or you can add event-driven aspects. So when you upload an image, you can optimize it or do whatever you want. When you upload an image, it can tell, when you have a new order, you can basically start the ordering process using event-driven. Or you can extend your application, add more features to it. Now have the whole shipping or whatever you need, and add it as a serverless component. So as I promised, this is the link to all the materials. There is around 30 videos here where I take you through all the migration in more detail, more slowly. Then we also do the app runner and the Lambda migration, and we do a Mongo to Dynamo migration. So there is quite a lot of steps in here and optimizations that you can do. So that's a link to save if you want to learn more. And yeah, that's it. I don't know if somebody's brain exploded, but that's a lot of information for.
My brain didn't explode. It was a lot of information, but as always, very clear, very succinct. Yeah, it follows a really, really interesting, logical kind of track, and it's really interesting to see the potential options and why you end up going with one service or another, because there are a bunch of different configurations that you could do to get your node app lifted and shifted. But speaking of one of those options that you went for, especially for the MongoDB Atlas, I just had a quick question of would there potentially be any performance issues with the database being outside of your AWS environment, or what could a database option like an in-house AWS option be for that?
I think if I will have to, if the time to do a migration, I think the best option is to go with Dynamo. In these links that is in the screen, you can see how I do it and why. because you invest the time to migrate your database from Mongo to Dynamo. It takes a time, and you will need to then refactor the code. But the good thing with Dynamo is that it has this single digit performance. So basically, you are inside the same account, same region, same everything, and it just works. It scales up with no limits. So that's pretty cool. But the Mongo option is not bad at all. It's just Mongo Atlas. It allows you to select if you want to have it in an AWS networking. It allows you to pick the region. So if you pick a region that is the same that your application that you are deploying, it will work pretty neat. The main problem with the Mongo connections, the Mongo solution, and this is not a problem of Mongo Atlas itself, it's a problem of the database itself, is that it has a maximum amount of connections. So basically, every time you work with that database, you need to connect to that database. And if you are in a ephemeral environments like Lambda, that you have so many functions running at the same time, you might hit that connection limit pretty fast. For the free tier, it's like 40 open connections, and you might need to, if you want to run this in production, you might need to have more connections. So you might need to start paying just for having those connections there. So that's, I think, is one of the biggest limitations. But if you are, for example, in the App Runner solution, then that's not a problem for you, because App Runner will be one connection per instance, and that's it. So zero problem, and it just works perfectly. And the performance is nice. Mongo Atlas is an amazing service. So why to break your brain doing unnecessary migrations until you need it?
Yeah, no, and to be honest, I even think Tailwarden. I'm not sure about the latest, but I think we still use MongoDB Atlas in the backend for our enterprise offering. I remember one thing, and there's actually a blog that I wrote about this around some latency issues that we needed to work out with which I think came from hitting the limit of those connections, as you mentioned. But cool. Thanks for that, and good to know that that there is an optimal way to do it with fully managed, like just all AWS managed services. I'm aware and mindful of the time that we have left, so I just wanted to quickly end off with two questions, if you don't mind. The first one being like around the future AWS serverless offerings, or to be honest, it doesn't even need to be only serverless offerings for AWS. But what in the future are you excited about? I saw recently a video that you put out around playing with Bedrock, which I think is a serverless generative AI service. That seems pretty cool.
That's what everybody is into now. At least for re:Invent, now is coming in November, our major event. I have a talk there that I'm very excited about it. That is how to automate some workflows, like my daily workflows. I work a lot with videos using Gen AI, and well, Bedrock is quite a cornerstone of that. For developers and for serverless lovers, Bedrock is awesome because you don't need to worry about provisioning anything. You don't need to train any models. You just use it from your applications with an URL, an API, and boom, you pass the parameters, you pass the prompt, and then you get a response. And that's like really, really cool. So that's something I'm very excited about, to build cool applications with generative AI and add more artificial intelligence into my applications. But for me, at the end of the day, it's always about building applications. AI is cool, but it's just a tool. So services like that are cornerstone, API gateway, Lambda, event bridge, and step functions are still the core of most of my workflows. And no matter what trend is on top, I will be using a lot of those. So
that's a good thing about trends, though. Like if you're into playing around and just trying out new things, you're never going to be bored.
Oh no!
So
and you learn a lot in the way.
Exactly, that's true. So my last question is kind of like two-pronged. First of all, is what is it like? What goes into your day of being a principal developer advocate, and secondly, what's your productivity function? Because you put out so much content. Like, to be honest, I don't know if like the what you do on your personal channels is part and parcel of your work at AWS, or is that something that you do at the site? But even if it's part of your work, you put out so much. You're very productive. So, what's your secret? How can we learn from you?
I don't know. I've been doing this for so many years, but yeah, the AWS developer advocates have two roles, as we call inbound and outbound. So this is outbound. Everything that you see from me in the world is outbound. So creating content, delivering the content, and putting it in all kind of forms is outbound. And then we have the inbound part that is as important, that is listening to all you guys, all your feedback, and sharing it with the service teams. We work closely with all the features. So whenever we are planning a new release, developer advocates are involved in that process, because we are the voice of the builders. So we know your pains. We try to understand what is in your mind, and we fight the service teams as we were you. Like saying, no, this is a horrible idea, don't do this, or this is quite cool, but maybe you should do this and that. And so that's quite a big chunk of our workday, meeting PMs, working with service teams, reading documents, and all these things. And the more principal you are, the more of that you have to do. But yeah, I love creating content. So I have been doing this for many years. I have a whole pipeline on how I do my content and how I orchestrate it and how I build it. So it's not, I don't know, I just show it so much. But yeah, everything is part of my work. So whatever you see out there, it luckily counts as work. I'm very privileged.
Very, very cool. And yeah, well, I'm kind of interested to learn more about like that pipeline and to know exactly how you organize it, because yeah, it's the content is just usually you're only getting a bit of quality or quantity without the quality, but in your case we get both, so it's really, really nice to see. So thanks a million for doing that and for putting out that incredible work.
That the white hair also help for that. You get the experience under your belt.
Exactly, there really is no substitute for it, right? Like your content, like, because yeah, like someone like me who's just been around here for 2 to 3 years in the cloud space, like of course I would love to like have a magic wand and increase the quality of the content, but there's no workarounds. That's going to come only with time, with experience, and with lifting and shifting a lot of apps. So so perfect, Marcia. Thanks a million. This has been really, really educational. I've taken a bunch of notes here, and I can't wait to jump into the links that you shared. Thanks a million for taking your time. And anything else you want to mention before we head off?
No, if you happen to be in re:Invent this year, just come and say hi. I will be around the Serverless Espresso, and I have a couple of talks. And I'm always very happy to meet people. So if you are going there, then just come and say hi. And I will leave you the link in the private chat of StreamYard for this material. So if you want to share it around, just, I don't know, do the magic and put it in the description or wherever you put all the info. But maybe that's where people want to head up and learn more about all these migrations.
Ideal. Perfect. Thanks a million for that. Yeah, later on today I'll upload this recording with all the links. So yeah, Marcia, thanks a million for taking the time. Have a great day, and see you at re:Invent, hopefully.
Yes. See you. Thank you, everybody. Bye.
Bye-bye.